This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Geometry, and Learning Target number 11. I can solve for missing side lengths of right triangles using the Pythagorean Theorem. So the Pythagorean Theorem is a relationship between the three sides of a right triangle, and a right triangle has a square 90-degree angle within it. And it says that if you square the lengths of the legs, which is the two smaller sides, and add those together, that will be equal to the square of the hypotenuse, which is the longest side. So there's going to be some squaring with exponents of 2 multiplying to itself, a couple pieces add together to equal the other one, and we're going to have to try and figure out some of those missing things. But if we have and I'll try and draw it up the top here, if we have a right triangle and the two legs are called A and B, those are the shorter sides that border the 90-degree angle, and the hypotenuse, which is the longest side across from the 90-degree angle, C. If this is our setup for any right triangle, then the formula where the two legs squared, the sum of the squares of the two legs together will be equal to the hypotenuse squared. So let's see if we can figure this out for this first triangle. On the left, I have got one side length. This is 4, and this is one of the legs. So this will be either A or B. And the other side that I've been given of 8 right here, that's another one of the two legs. It's one of the shorter ones, and it borders the 90-degree angle. Now, really, since you were just adding the squares of them together, it doesn't really matter which one you call A or B, because addition is commutative, and it doesn't matter which value comes first. So I'm just going to call this one A. I'm going to call this one B. You would get the same result if you had switched those, and 8 was A and 4 was B. So no big deal there. All right, so the side length that I am looking for, I am going to call this one my hypotenuse C. All right, so the relationship is that A squared, and I'm gonna, you know what, I'm actually gonna do this in a different color so I don't get this mixed up. So call this your hypotenuse C. So A squared plus B squared equals C squared. So my A value is 4. So I'm gonna say 4 squared. My B value is 8, so I'm going to say 8 squared. And then my C is my unknown, so here's my C squared. So now I have an equation with just one unknown, just C. Now I can figure out what C has to be. So let's evaluate some of these exponents. I've got 4 squared. 4 times 4 equals 16. Remember, that's not 4 times itself twice. That's not 4 times 2. It is 4 times itself twice. It's not 4 times 2. So 4 times 4 is 16. Answer is not 8. And then 8 squared, that's 8 times itself twice. That is 64. So 8 times 8 is 64. So the sum of those two things is going to be equal to the hypotenuse squared. All right, so now let us add up the 16 and 64. I think I know what that is. Yes, that is 80. So I'm going to get 80 is equal to C squared. And now I've got to figure out what that C squared has to be. So what number can I multiply to itself twice to get 80 as an answer? Well, let's see. It can't be 9 because 9 times 9 is 81. So I think it's going to be just a hair less than 9. It's going to be 8 point something. So you're going to need to do your square root to undo this square. So I'm going to take the square root of both sides to figure out what that is, because the square and the square root are opposites and cancel. So C is going to be equal to whatever the square root of 80 is. I'm going to approximate that here on my calculator. Square root of 80 is very close to 9. It's 8.94 approximately. So I'm going to cut it off at a couple decimal places, 8.94. So now what we want to do is double check that this value makes sense. What I mean by that is your hypotenuse C should be the longest side length. If I got an answer of 6 for C, I would be worried because 6 is less than 8 and this side length is supposed to be the longest. In this case, I approximated C as almost 9, and 9 would be the biggest of those three numbers, so a number of approximately 9 is very reasonable for C here. All right, let's try the next one. All right, let's see what we've got here. I've got one of my legs. I'll call this one A. And it's one of the legs because it's one of the shorter sides. It's attached to the 90-degree angle. And I've got my other leg, and this is my unknown this time. Okay, I'm going to have to figure this out. I'm going to call this one B. And this time I am given the hypotenuse of C. I'm given 7.4. This is the side length that's across from the 90-degree angle, so that's going to be your C. So now I'm going to have my unknown in a different place in the equation, and I'm going to have to do a little bit of moving around to figure out what B is in this case instead. So remember, my formula is A squared plus B squared equals C squared. And in this case, I'm going to be replacing the A and the C with values instead and leaving the B as my unknown. All right, so my A is going to be 3.6 squared. My B is, I'm not sure, so here's B squared. And then my C, I have been given at 7.4. All right, so now let's see if we can figure out what this has to be, 7.4. There we go. Now, when I'm solving this, when I do get a value as an answer, I want to make sure that this side length here is going to be less than 7.4. See, the hypotenuse is always the longest length. So if I get an answer that's larger than 7.4, I know that I've made a mistake somewhere. All right, calculator is going to help me out here with some of these squaring numbers. 3.6 times itself twice is 1296. All right, 12.96. And to that, I need to add B squared in order to get my hypotenuse squared, whatever 7.4 times itself twice is. Let's see. I got 5476. 5476. All right, now I've got to figure out what B has to be. I think it's going to be easiest if I, let's see, because 12.96 plus my something is going to equal this. If I subtract that away, then I'll know what that remainder is. So let's get rid of that 1296 to figure out what B squared has to be. 1296. All right, calculator's helping me out here again. 5476. Subtracting 1296, 41.8. This is supposed to be a 9. Okay, so my B squared is going to be equal to 41.8. Now, note that this is not what the side length of the triangle is. That's B squared. If this side length were 41.8, I would be very worried because that's over the 7.4. So that is that side length times itself twice. So I've got to figure out what number can I multiply to itself twice to get me an answer of 41.8. Let's see. 7 times 7 is 49. It's got to be less than that. So it's got to be less than 7. But 6 times 6 is 36, and 41 is bigger than that. So it's got to be somewhere in between 6 and 7. If you do the square root to cancel the square, then your calculator will tell me exactly what that has to be. Well, approximate anyway. So I'm going to take the square root of 41.8 and I get, yep, somewhere between 6 and 7. It is 6.46 approximately. If you round up 6.47. So 6.46 7. And that is reasonable. That was what we were hoping. It had to be less than 7.4. It does also by this look like it needs to be bigger than 3.6, but can't always trust your eyes with the diagram. Sometimes the numbers are a little bit incorrect. So just to remember, a squared plus b squared equals c squared, where c is the hypotenuse of any right triangle, and a and b are the legs. Those are the ones that stem off of the 90-degree angle. If you follow that formula to solve for either the hypotenuse, what c has to be, or one of the legs, a or b, and it doesn't matter which one you call a or b, as long as it's those two lengths that stem off of that 90-degree angle.